Thank you very much. So when I was creating the presentation, I was looking and I knew I did this once here and it was in 2019. And I think everything has a before and after period these days. So at that time, actually, we were talking about, they asked me to do a presentation what data could mean for Wi-Fi in order to get better visibility, better security, make sure you can maybe optimize things or do easier troubleshooting. And there was also a Q&A at the end. And actually, I asked a question at that time to the product owner of Ekahau. And I said, but what is Ekahau going to do with cloud and AI? And actually, now we are 2 years later, and I'm pretty impressed actually this morning by the update they did. So that was very good for me. So now they said they wanted me to do a presentation about Wi-Fi 6E, but I didn't want to do an average 6E update because I think you probably know more about 6E than I do, and you probably also know way better how to implement it and how to deal with it. But I want to give it a little bit of a different perspective. So let's see if that will work or not at the end during the lunch. And I want to have a few topics to discuss. And as I said, I'm Dobias van Ingen. And maybe I'm not sure I'm the only non-native English speaker today, then bear with me, but I'm from the Netherlands. And I'm working 23 years in HPE and like 20 years in networking or so. And at the moment, I'm EMEA CTO and Senior SE Director. And I'm happy to be here. I love this community kind of events where we can all share and collaborate on technology. There's a few topics I want to discuss in my presentation. The first one, and by the way, thank you for everybody that did bad Wi-Fi pictures. So I used a lot. I tried to use only Aruba version, so not to make everybody else another vendor bad. But you can see here an outdoor AP is not really right installed. But the first thing I want to do is what is the state of the nation of Wi-Fi 6E? So where do we stand for? Why is it key for us as a community? And how can we drive innovation forward? So that's the first thing I'm going to do. But I'm going to do it differently because I'm going to take an EU approach. Because everything I see is a FCC US kind of approach. And I know that most of the vendors probably come from that world. So I want to take an EU approach. And I do know we are not completely in the EU anymore, so let's also take a UK kind of approach to this one. Then I also want to talk about devices, because in the end, devices demand what we need to do on the infrastructures. And we got weird devices out there. This is a device that you can put in front of your mouth, and then you can talk privately. So you can talk privacy, or you can make sure you don't have a lot of noise. It's going over Wi-Fi, so you can measure a few things. But you see these days, you got more and more Wi-Fi devices that are very special. And then the last thing is I want to have some design fun. And the design fun is, at first statement I'm going to make, all the theoretical numbers are there. I do know that they are theoretical, but I think it's good for us at least to have a starting point to start a discussion. And then I'm going to take some, let's say, different approaches to the spectrum we have and how we can use that spectrum. And I'm not saying I'm true or I'm right, but let's have a discussion. Maybe I heard beer is after lunch already. So that's another good thing. Then maybe over beer we can discuss if that makes sense or not to do it. So that's a little bit the three main topics I want to discuss. The first thing is why 6 gigahertz is important. In order to do that correctly, we need to look at how we as Europeans connect to the internet. And if we look at that one, is that most of us connect either via DSL, maybe fiber to the home or fiber to the business, or maybe we can connect via cable or something like that. And there is maybe a few that connect on satellite or on LTE or 5G connections. But 90% of the people that work, they work indoors. And what you see is that the last mile bridge, actually, not from a provider perspective, but from an infrastructure perspective, is Wi-Fi. So that means if they 90% work indoors and 90% of the work is being done indoors, then Wi-Fi is that last mile. That also means that 90% of the traffic is going over Wi-Fi in that particular, and then it hits the fixed lines more or less from the internet provider. So if that's the case, then have a little bit of a look at what fixed lines means for us. What you can see here is two slides more or less. Two graphs. One is Germany. That's the total amount of traffic in billions of gigabytes going over fixed lines compared to, for example, mobile traffic. You can see the difference. It's huge. The other factor is this one, is where you can see the UK and I, the percentage of traffic versus mobile versus fixed. You can see almost 95% of the traffic in most developed markets in the world is going over fixed lines, with the last mile being wireless in that perspective. Then, this is another funny thing, and this is another research being done where you can see fixed network traffic forecasting, so to say. What you have here is the first thing on the UK. You can roughly see that there is a compound annual growth rate of roughly like 20% of the traffic growing over these fixed lines. So that means about 2025, they probably hit like the 1 terabit. If you calculate that further, you will have in 2030 a 2.7 terabit per month per household in the UK and I going over fixed lines. Then in Germany, they roughly have like a 30% growth or something like that, and they come like a 2.6 terabit on there. So I have 3 sons. I think I have 1 terabit per day with my 3 sons actually on all their Instagram and videos and gaming they do. So I have many, many more, but you can see the amount of traffic that is going forward. And this means, another thing is UK and I also have a very prestigious project. You can say in 2020, you can see here, France, Spain and Italy were #1 in fiber to the home and fiber to the business. So to deliver gigabit speeds or more than gigabit speeds to every business and every household. In the UK, by 2027, they will roughly almost have a 300% growth of that fiber to the business, meaning they get over 1 gigabit speed with the last mile being wireless. And that's why that additional spectrum for us is so key and able to keep up. Because if we're looking at devices, we did a research, and if you're looking at channels being used, 40% of all the channels being used is like 20s, and roughly like 51% of the channels being used is like is 40s. So only 9% is being 80s. So that means if you want to develop and innovate on application perspective, and you need to keep up with the growth of the data and drive the innovation there, you need to make sure that you get the spectrum and drive new kind of networking. On the other side, you have the devices. By I think there was 2021, by research by Gartner, is like 6.2 billion kind of client device connecting on there. And there is new devices coming on there, but these new devices probably also need new demand, new delivery, new services, whatever is needed in order. And you don't want to slow down your network by legacy devices. This is why 6 gigahertz is so important for all of us actually as a community. But it also comes with a responsibility. And as vendors, believe it or not, but sometimes we also work together. And as wireless vendors, we do a lot of work in driving additional spectrum. And we look at the spectrum later also in the EMEA market. Because keep in mind, we only have 500 megahertz roughly as a spectrum. So, but us as a community need to take that responsibility also and making sure we get that additional spectrum just to meet up with these demands and making sure we can meet up on the innovation, on the services, or whatever kind of infrastructure you're delivering in the market. So what is the momentum? This is from the end of January. This is done by the Wi-Fi Alliance. And you can see here is by 2021, the UK and the EU roughly has adopted that lower part of the market. And that's been interesting. If you have seen over the years, and I put some dates on top of that, but you have seen over the, and by the way, you will get these slides, so you can take any picture you want. Maybe you don't want me. If you want me out of it, you need to say it, but you get the slides from me. But this is an interesting one because look at it, 58 countries by the end of January have been adopting 6 gigahertz. It's more than, it is roughly, it's a little bit more, but it's 1.9 billion citizens that are potentially being covered by it. So it's a huge, huge momentum. And that's why I think we are all responsible in driving that market forward. So let's look at some history. The history here, 1985 was the first unlicensed spectrum that we got. Let's say a little bit less than 200 megahertz in the 2.4, and there was also something in the 5.8 band. Then in 1997, I think you were showing Uni 1, right, in your presentation. That was not discussed up front, but 1997 was the first 5 gigahertz band Uni 1 and Uni 2A band. So there was also 200 megahertz. And then in 2003, so see the timing that is between them, is where we got the Uni 2C band of 255 megahertz being able to use. And then out of a sudden, in 2020, the FCC took the decision to deliver like 1200 megahertz. So that's roughly 3 times the amount of unlicensed spectrum available, but not for us. We have roughly 2 times the amount of spectrum available, so that's 500 megahertz. So let's look at this and see what we get. So here in the US, so let's say 3 times, but for us that's 2 times. We don't have 7 160s, we got 3 160s. But the important note is underneath here. We can't use this spectrum as a greenfield. There is no legacy to play with. So that is really good from a device perspective or high-speed lanes, but we get back to that one in some of the design thoughts or fun, actually, we're going to do. So that's a little bit what we can do. It's a greenfield spectrum that we can start using for anything new on there. That's a good thing to realize. Then, what is this spectrum? You can see the US, and I will not have much more under the US than this, but you can see here the European, and everything where you can see a little dot is where you can see the PSC channel, but I will not dive into all these details in there. But probably in the US, they will move with 80s and 160s. This is not only because of the amount of spectrum, I get back to that one later, and probably here, 20, 40, 80s will probably be used in the EU and the UK market. But this is the spectrum that we have available. You can see that there is multiple bands from 5 up to 8. We are working in 5. This is a double click. This is from the WLAN professionals. If you want to look at it, you can download it yourself. Double click on the spectrum. So it's 2420s, 1240s, 680s, and 3 160s. So even though I was complaining, maybe I sound like I was complaining, and I'm Dutch, so maybe that's the reason why. But here is, we also should be happy, because let's put it in perspective in 5 gigahertz. With 5 gigahertz, you roughly have also, let's say 480 or 500 megahertz available. But if you remove the DFS out of there, you have like 920 or like 920 non-DFS channels to play with. So now, suddenly you got 2420s more. So even though we want more, we always want more, but this is already amazing additional spectrum that we get. The downside of these channels, the advantage of the channels is that there is no DFS in there, so you can use all the channels like you want. So you have a lot of flexibility to play with. So what is Wi-Fi 6? And I also see a lot of things. There is no such thing as a Wi-Fi 6E certification. So we don't need to go as a vendor to a Wi-Fi 6E certification. There's Wi-Fi 6 certification, and Wi-Fi 6E is Wi-Fi 6 in the 6 gigahertz band. There is a few enhancements, and there's a few mandates that you need to work with. So in particular on that side, you can see that there is some new methods for in-band discovery, that you don't need to scan all the spectrum. You maybe have multiple BSID beacons, you have fills, there's many other things that there is available in there. There's security enhancements, and I got back to that, but more or less WPA 3 is mandated. So there's no way that you can do things other way. And there is some enhancements also in 2.4 and 5, also in the way you can see for our out-of-band management. So that's on the reduced neighborhood reports that you can see. And if you want to have more content, I can give it to you. And I have a lot of slides on all these individual subjects, but that's not the goal of this session. So you can see that there is some enhancement on top in the 6 gigahertz band, and there is some additional things that you need to consider for 2.4 or 5 in order to do out-of-band discovery or what kind of security mechanism you're using. So here is something on power. And I think everybody is probably used with the equivalent isotropic radiated power, so ERIP, and I'm not going to repeat it again. I'm happy that it comes normally out of my mouth the first time. So ERIP is what you use in the 5 gigahertz bands only. There is a big change in here, is because in 6 gigahertz it's not just ERIP. It's also now PSD. So you can see power spectral density. And that's the measure per hertz, per frequency more or less. So if you have 10 dBm per hertz, it's 10 dBm per 1 megahertz, as you can see it here. So that is the PSD, and that's actually, this is for Europe, and I get back to some of the other things. ERRP is a big thing in this industry. And I'm not going to talk a lot about Aruba because I think this is a community, so I will not talk too much about it. But one thing, this is how we calculate ERP because I got tons and tons of questions on this. It's per chain conducted power plus MIMO gain plus antenna gain. That's how we measure it. I'm not saying this is the perfect thing or every, but if you're comparing APs, I get back also to Ekahau later on, but you need to keep in mind that sometimes these things are measured differently. So ask whatever your vendor or your SE or somebody that knows it, how is it measured? This is how is it measured in Aruba, and you get the slide, so then you have it forever. I'm not saying we measure it for this forever, but at least we do it for the last 10 years, we measure it like this. The other thing to keep in mind is that the one that is restricted first applies. So ERP and PSD. And I get back to that one in the next few slides to explain that. Because let's say, what are the rules for us here in the EU? There is low power indoor devices. There is for us in the EU and in the UK, so I get back to the UK, hold on that one. But the EU is 10 dBm per megahertz for PSD and 23 dBm ERRP. That's the rule. No standard power APs or no standard power devices in there. So, and there is no possibility in using the other bands for low power. So only that lower 500 megahertz in the Uni 5 band. These are the rules. But the UK took a different decision. So they have 250 milliwatt or 24 dBm. So that's in there, but it's roughly the same thing, so to say. They also have a little bit more spectrum, but at least you have the rule how it is here. Now let's move forward, because this is the thing where I see it going wrong in most of the presentation, and not wrong, but not seen from the right perspective. So here is what is I see many, many times on the internet and somewhere else in many presentations. And this is the FCC rules. So FCC rules, 5 dBm per megahertz plus a max ERRP of 30 dBm. And what is happening here, and the reason why they do this actually makes sense, to be honest, is that if you double the channels, you double the noise. So if you go from 20 to 40 plus 3 dB, if you go from 40 to 80 plus 3 dB, so you got 3, 6, 9, 12, roughly. So what they do is they are then allowed to skip up in higher ERP to overcome that noise. So more or less your signal to noise ratio stay flat across the channels. And the advantage there is that you are more able to move to larger channels because the signal to noise ratio stays flat. That's in a very simple way how I understand it. But, this is US only. So now, let's get back to our beautiful Europe and UK. And that's not the case. That is not the case because we have ERRP of 23 dBm flat. So what is happening is you go across these channels, and then it sounds nice that you have 10 dBm per megahertz, but in the end, your signal to noise ratio still goes lower. That is an important thing. I don't think it matters so much because if you see at the 80s, you get that 17 dBm, and I know most of you probably design around 18 dBm. That's what I always hear from a design rule. Let's look if that's true later on. But that is what I hear from a design perspective. So I don't think this is too much a problem, but I'm not sure, are these sessions recorded or not? Okay, so then I'll be careful. But the thing here is, more or less we got double screwed, so to say. So we got less spectrum, plus we got less power in the higher bandwidth. So it is a thing to consider when you start designing. That is not the same as the US. This is how it is in the EU. I'm not saying that it stays as this, but this is how it is right now, and maybe it will change, maybe per region or whatever, the regulatory bodies will comply. So you will get the slide, so you have this information. Ekahau, ERRP, I'm not sure it's still the case, I think is this one. So if you're working with an Aruba AP in Ekahau, keep in mind that we do per conducted power, MIMO chain plus antenna gain. AKH does per conducted power plus antenna gain, so they don't do the MIMO gain. And by the way, don't get me wrong, there's no good and bad in this. It's just a different way in measuring it. But for indoor, this doesn't matter so much. But if you do an outdoor design, for example, with Aruba APs, keep this in mind. Then you can see how you can adjust that. You can also make it part of your planning. But you need to keep it in mind if you do designing to do this correctly for your customers or organizations that you're working on. It's still the case, right? Okay, that's good. So let's look at device classes and operation in there. I already said there is low power indoor and there is standard power indoor. But we don't do standard power indoor. And what is then the difference between the two? Low power indoor, fixed antenna, or let's say in antennas, no external antennas allowed. It's not even allowed to do battery powered APs. There's no weather proofing or sun proofing or rain proofing or this kind of cases allowed. So that is the rules around low power indoor. Then standard power indoor, this is where you maybe heard something about automated frequency coordination database. So yes, of course, we work at it as a vendor and probably all the other vendors work for it. But at the moment, it's not allowed in the EU to do standard power indoor. So in standard power indoor, you're also allowed to use external antennas on your AP and use indoor, outdoor. And then you also have something called very low power. This is more, for example, maybe direct connection for HoloLens or something like, well, there's many more use cases, but I'm not going to talk about that in my presentation. So low power indoor only. I also made this one. And again, here you can see more between the differences between what is the difference between all the different powers and settings. But again, my cross there is that we don't have this one. So let's move on. About security, I already said that WPA3 is mandated. So you will need to use WPA3 Personal, WPA3 Enterprise. You can select some of the cryptographics, that's optional. You need to use protected management frames and enhance open, if, for example, for OWE for guest. So no web, no WPA2, transient mode is there, but I'll get back to that one later on. And then this is interesting because you need to think about now what devices you're going to put on there and how you're going to do your SSID planning. Because maybe you need to rethink about how your security mechanisms in there, because this is mandated in these devices. So let's move to what kind of devices are there. And this is another interesting. On this table, you can see on the x-axis the amount of quarters up to 500 certified products it took after the program launch. So you can see 2.4, 5, and 6. The adoption of devices is around twice as fast as we saw with 5 GHz. It is really, really mind-blowing at the moment how fast this goes. Then, what are these types of devices? This is, by the way, Q2 22, but you can make your own graphs on the Wi-Fi lines if you want to. You can see here, the dark one is the PCs, and then you can see the access points, some smart TVs, some other devices on there. So you can see the adoption is really rapidly growing on 6 GHz devices. Then what are these devices and what are these chipsets? So here's a little bit of a rough summary. So you can see chipset, of course, is Intel. Probably most of you have some of the AX chipsets which do in Windows 6 GHz. Then you have some phones in there. And then you can see the chipset is Qualcomm, Broadcom, some LG. There is many, many chipsets. Intel is in there. Many chipsets out there now that give you the possibility to build new devices on 6 GHz. Also, you can see here some of the USB dongles out there. And yes, you are an Apple fan, right? Man, we are finally happy that I always buy the new iPhone, and I didn't buy the iPhone 14 because they didn't add Wi-Fi 6E in there. So, but now I'm happy to see that the MacBook Pro, the Mini, and the iPad Pro is moving to Wi-Fi 6E also. So happy that Apple's now moving on this bandwagon also. Now if they also start doing 11MC or something like that, we will be even more happy. But that's another discussion, not for this session. But at least Apple's now on the boat on Wi-Fi 6E. So I expect the new phone also to be there on 6E, and I can buy a new phone again. So let's have some design fun. And let me state this here again. I'm not saying I'm right on this, but let's have some ideas about this, right? So what is these numbers? Again, these numbers are theoretical. I'm very well aware of it. But we need to work with something. this is the amount of additional spectrum and additional bandwidth we get, right? You can see 6.8, 6.8 in the 40s, 7.2 if we take all the 80s, and we have 7.2 if we take the 160s. This is roughly what we have. You can here see the OLED column again. Think about that power level, that is important. So what can we do then? What do we need to think of? So a lot of maybe networks will be one-on-one replacement. I will discuss that a little bit later, but we also need to think about power. We need to think about performance. We need to think about performance on Wi-Fi and performance maybe to the switches. If we go above 1 gigabit, if you see with these kinds of plans. We need to think about security, SSID planning. So let's go through a few. And this is a simple diagram that we made to think about, okay, what if we have power? So here you can see what channels you're going to use. Probably we are going to use 2040s, but I also think there is a use models for 80s if we do it smart. But I get back to that one later on. Probably in the US, they will have more spectrum, so they probably move it to 80s and 160. I know you guys did a survey in Prague about the question, so I think this is probably right. We already made that slide before the survey, by the way. But this is about what you're going to do to one-on-one replacement. I think you called it, you had now the tool, I never saw that, but I saw it the first time this morning, where you could rip and replace. I have a different phrase for that. I think, I'm not sure what the name was for the feature, but I think you had a nice name for it. I always call it shit in is double shit out. So if you design for coverage, you need to think about, can you do a one-on-one replacement? If you go for capacity and everything is designed right, secondary, primary channels, the right signal to noise ratio, then you probably can take like a -1, -2 dB in factor for 6 gigahertz. So you're probably on the right spot. So here you can see my simple diagram to choose. If you have more than 20 dB on that level, you need to make sure you probably need to increase if you want to do a one-on-one replacement. If you have a less than 20 dB, you probably are fine, and you probably take that 1 or 2 dB into consideration, and you can start to removing, or you can start to swap the one-on-one replacement. This is a question we get a lot, can I do one-on-one replacement? This is it. But also think about other things later on, but we will look at it. This, for those that don't know Aruba Central is our cloud platform where you can manage the products. This directly comes from Aruba Central. Everybody designs for 18 dBm. That's what they say to me. But here you can see this is data. This is more than 2 million data points for 5.4 and this is 5.4 and 2.4. So you can see here that roughly, let's say a little bit, 55% of the devices are configured to be set at 18 dBm. But you can see also many more devices goes higher. I need to take one thing in consideration. I think around, and this is a little bit of a guess, but I think around 10 to 15% part of this data set is also outdoor APs. But I think it's interesting to see this ERP. So what about 6 gigahertz? And 6 gigahertz is not 2 million. I wish we already had 2 million devices, but this is not 2 million, so it's a lower data set, but you can see that the power there is around more than 80% of the devices. Well, guess why? Because of some of the power settings in there. But that's where you can see how most of the network are configured. I think it's an interesting graph to look at it. This, again, is a US focused slide. The only reason why I'm mentioning is you can do your own calculation here, is if you have one single AP and you do all 3 bands, and you can get up to a certain factor of performance, right? And that performance also comes with power. So you need to look at, what is my power over Ethernet? You need to look at, can I connect that bandwidth? Do I expect the bandwidth first? That's number one. If not, maybe you don't need to upgrade. Maybe you do need to upgrade. What about redundancy? So take these things into consideration. So what about SSID planning? And SSID planning is really funny now because you get the difference with the security mechanism. Here is what we have been doing, I think, well, for maybe 20 years. Get a few SSIDs. Sometimes I see 14 SSIDs, but let's say somewhere between 2 and 4, where we put maybe 1 PSK for IoT, guest, and corporate. But what if now, with the new spectrum, we can clean up completely the 2.4 band just for IoT and put some corporate and guest to 5 gigahertz and maybe some high-speed lanes on the 6 gigahertz band with a special SSID so that everybody knows it and everybody can attach to it. But this is where we can start driving this because we have that different security. We can really use it as a greenfield. So here you have the different security mechanisms that are available. I'm not going over this all one-on-one, but you can see the different security possibilities. Keep in mind, WPA transition mode is there, but believe me, that's not the most efficient way to build Wi-Fi. WPA3 transition mode is inefficient, so to say, inefficient. So that's, if you need it, I do get it, you need to use it, but if you can avoid it and design it correctly, then don't do it. As I said, shit in is double shit out. So that's one thing. So what about this one? This is amazing, right? So let's go to some fun exercise here. What if we can start building layers now out of a sudden? And I'm going to tell you another thing up front. This is not just to sell more APs and switches. That's one thing. But most of the times when people talk about innovation or doing things different, I see this kind of behavior, right? We are too busy, we don't look at it, let's not think about it. So we are now here, we have nothing to do, so we can start thinking about it for a few minutes, and then we go for lunch. Here's the general rules, I think, for coverage. And I know there is many rules, 10 to 15 meters, but I had to pick something, right? And don't blame me for it. You can do the calculation on your own. So there's a few APs here. Think about the coverage, 10 meters apart. There's 40 and 20s. So we take, I took the meters. Let's say, but I also squeezed it down a bit. So in the US, they always speak about, 25,000 feet. I just try to make a little bit smaller kind of sessions here. So let's look at that one. This is the official rules for an office building in the Netherlands. And I think it's a NEN norm, so I think probably across the UK and EU is probably the same, roughly the same thing. So they say an employee needs roughly like 7 square meters. So let's say in the example, if we take a 100-person building, we got 700 square meters. So how does it work out when we start reusing these channels? So here you can see a little bit my calculations on this one. You can see the graph when you start to reusing the channels roughly, so to say. As you get, if you have 160, you only have 3, you quickly go into reusing the channels. But you can see if you have 165 coverage, square meters per AP, you have 5 in total, you can see how can you, per floor or whatever, multiple floors, how you can start building out these network infrastructure. So what if you need to build a network that maybe needs to be multi-tenant and you really want to have separate infrastructure. Maybe one for IoT building, maybe for the video cameras, or maybe for voice on 20s and non-DFS channels, whatever you want to do, you can do it here. So then maybe there is an option now to start using the 40s and 6 gigahertz. Then we're using 49% of our channels, and maybe we use the secondary 20s, then we have another 25%. So this way we can start layering these infrastructures. This is what we have been doing over the last 20 years. And probably many, many networks will still being built like this, where we have all the SSIDs on one single AP, or not on one single, but on the AP, and then across all the bands, on the 6, 5, and 2.4, and you can roughly see calculation of bandwidth that you theoretically can get out of this. But what if we start layering and partitioning this and really start thinking about this? And that there's many, many times in the past that I've seen, for example, in healthcare, and I think there was a healthcare session at the end of the day, where they also try to build layers of some form of wireless solution. And I think now we really have the opportunity to do it. So what if we can do this? And let's say we put 2 SSIDs. For example, maybe we put clinical imaging on the 80s, right? If you are talking about a healthcare. Or if you're talking about a teacher's network, sometimes you can maybe you can really build separate layers. And I do understand you need double cabling and everything for this. But you can start building layers of wireless with the spectrum that we have now, even with the 500 megahertz. So here, I think, 5 to the 1140s go on 5. Then you have actually that should be 3 times 20. 3 times 20 go on one AP, and the other AP just focuses on the 6 gigahertz on the 80 channels, maybe for criticality or, as I said, clinical imaging, video, education, what you can do. And then you don't do the rest. But another possibility will be another one with 2 layers, will be this one, where you can say, okay, for the 5, I'm going to use the non-DFS channels just for voice, maybe, or critical voice, and I'm going to use the other ones maybe for guest on the 5 gigahertz. I'm going to use that for guest on the 6 gigahertz also. On the corporate traffic is going on the 6 gigahertz also, and then on the 80s maybe clinical imaging or other kind of application. This one is also interesting, and this is actually, I had a real discussion with a manufacturing line on this one. This is a 3-layer AP, where you can see here, again, maybe for voice, a non-DFS channel or something else, guest is moving to one of them. The last one you will say, okay, hey, that's weird, the 8 times 20. But what if you have a manufacturing line? And in the manufacturing line, for example, you have cars, or you maybe have consumer products. And sometimes these days, these products get updated in the manufacturing line. So they need to get a firmware, they maybe need to get multiple software upgrades in their manufacturing line. Then you maybe want to have one separate layer of a Wi-Fi infrastructure that is just taking care of these updates. Because the only thing you don't want that sometimes the people can't work, that's one thing. Stopping a manufacturing line, that's not what you want because the Wi-Fi is slow. So if you can start building these layers, you can start building layers of services with multiple APs. So you really can start using that spectrum to do smart things. And of course, we can always do what we always have been doing, putting everything on one AP, all the SSIDs. But this is something that you keep in mind in manufacturing, in healthcare, or in other kind of designs where you can start thinking about layers of Wi-Fi infrastructure on separate APs. And of course, you can still manage it from the same platform, but you can start thinking about these based on the services, based on the requirements that you have, you can start thinking about that. And that's actually where I want to leave you with. And then you are done with this Dutch guy on stage. And I think there is now, not sure if the beer will be there. I can't promise you that, but at least I know that there will be probably lunch. So thank you very much.